All right, for the second half of our video, we're going to be looking at inverse trig ratios. Now, before we move on with that, I want to look first at just some simple trig ratios. Going back to what we looked at in our first video, we found that the sine of angle 30, or 30 degrees, would be 1/2. I want to show you, if we were looking at that like on a calculator, sine of 30 degrees, exactly how you'd type that in and what that would look like. So I'm going to bring up this screen. Now this is a Casio FX9860. It's going to be a little bit different than some of the calculators you have, but it's going to look fairly similar. This one is just the screen. These are the buttons that you push. Now before we can go into using any of our trig functions, we need to set up the calculator. So hit Shift, that yellow button, and above the menu you can see where it says Set Up. So go to Set Up, scroll your way down, see where it says Angle here. Right now our angle is in RAD, that is radians. We don't want our angle in radians. Scroll down, it gives you three options: degrees, DEG, radians, RAD, and gradients, GRA. We want degrees. We are looking for everything in degrees, so hit this F1. Make sure it is in degrees. And you can hit exit and come back. So now we are measuring things in degrees, not radians. So if we wanted the sine of 30, we would literally just hit the sine button, type in 30, so this is the sine of 30 degrees, hit enter on that. This calculator gives it to us in a fraction mode. It would say 1/2. Otherwise, if you didn't want it as a fraction, F to D will give it to us as the decimal 0.5. So sine of 30 is 1/2, or you can call it 0.5, either one. Okay, which again follows along with what we said in our last one. Sine of 30 should be 1/2. So that one fits. Okay, that's how you type it in on your calculator to figure those things out. Now, looking at questions like this one. For this example, it says find the measures of angle E and angle F. Well, first let's look at angle E right here. According to angle E, this side would be opposite, this side would be the hypotenuse, this side would be the adjacent. According to angle E, what we're looking at, we know the adjacent and the hypotenuse. So the A and the H, which means we can say cosine, because cosine goes with adjacent and hypotenuse, cosine of E equals 12 over 13. We know this for a fact because we know the adjacent and the hypotenuse. If we want to get rid of this cosine, though, to find out exactly how big angle E is, we would have to do what's called the cosine inverse. This is an inverse trig function. It basically just gets rid of that cosine. What you do to one side of an equation, though, you have to do to the other. Oops, not an S. We need cosine inverse. So what our equation says now, that cancels out, and we would get that angle E, probably put the angle sign there, equals the cosine inverse of 12 over 13. So for me to find exactly how big that angle is, I just go over to my calculator and I would type in, you hit Shift, cosine, that gives you that cosine inverse, so cosine to the -1, and then in parentheses I just write my fraction, 12 over 13. So this is the cosine inverse of 12/13, and it's going to equal 22.619, bunch of junk afterwards. Just round it to 22.6. Always just round it to the nearest tenth. So we would come back and say, okay, angle E equals 22.6 degrees. We found the exact measure, well, a rounded measure of angle E without having to use a protractor to measure it. We know, because of trigonometry, it has to be 22.6 degrees. So if we do the same work for angle F right here puts us in a new perspective. This is not the adjacent, this is the opposite. This wasn't the opposite, this is the adjacent. This is still the hypotenuse. The hypotenuse part won't change. So now we know opposite and hypotenuse, which means we know the sine. We would say sine of angle F equals 12 over 13. we're still using the same fraction, 12 and 13, but it's not a cosine of the angle. This is the sine of angle F. So to get rid of that sine, what do I do to both sides? Sine inverse. Just use that little inverse button again, which means I can now say that angle F, the measure of our angle, is going to be the sine inverse of our fraction 12 over 13. So to figure it out, I just plug it all in. I do sine inverse instead of cosine inverse of 12 over 13, whatever that comes out to be, 67.380, some extra junk at the end of it. We'll just round it up to 67.4. So we would say 67.4 degrees, which is kind of nice because 67.4 and 22.6 will add back up to 90 degrees, plus this 90-degree angle means this whole triangle adds up to 180, which works. We want it all to add up to 180 degrees, and we did. We used our trigonometry to find out exactly what these angles would be, and it all fits. Oops, wrong direction. So we need to find the measures of angle J and angle K. Well, again, if we're looking from angle J, we know the opposite and the hypotenuse. So we would say sine of J equals 9 over 11. So we'd have to take the inverse sine on both sides. So, oops, if I did the inverse sine on both sides, this would get J alone. Angle J equals inverse sine of 9 over 11. And we just figure out what that equals. Now I'm going to do from angle K, we don't know the opposite, we know the adjacent. And the hypotenuse stays the same. So adjacent and hypotenuse means we're looking at cosine. Cosine of K equals 9 over 11. So I use the cosine inverse on both sides, which cancels that out. So we'd have angle K, K being equal to cosine inverse of 9 over 11. So to find out exactly what these equal, I just do sine inverse of 9 over 11. I get 54.9. I do cosine inverse of 9 over 11. I get 35.1. So I come back here, I just write in my answers, 54.9 and 35.1. And each of these are degrees because it's the measure of those angles. So that's how we could find our missing angles here using just these two values. We didn't even have to solve for this third side. We didn't have to use a protractor. We could just figure it out. So what is the measure of angle G if we know that the cosine of G is going to equal 0.53? Well, again, to get rid of a cosine, you would just do cosine inverse of both sides of this equation. Which means in the end, G all alone, just angle G equals the cosine inverse of this amount, 0.53. So I would just go to my calculator, cosine inverse. You don't need parentheses, but if you wanted to, you could. 0.53, so 57.9. Since it's 0.99, we can even round it up and just call it 58. So we will say angle G equals 58 degrees. What is the measure of angle V if the tangent of angle V equals 2.25? Well, to get rid of a tangent, it's tangent inverse. Just like sine inverse and cosine inverse, you can do a tangent inverse, which means then angle V equals tangent inverse of this amount, 2.25. So just plug it all into the calculator. Second, the tangent button, so it's tangent inverse that we're looking for. Tangent inverse of 2.25 comes out to 66.03. So we'll round it to 66 degrees. And last one, measure of angle M if sine of M is 0.978. Now none of these fit in with our the ones that we knew from that table. Otherwise we could just say, all right, if the sine, let's go back to the table, if the sine came out to 1/2, I would know right away, oh, that's a 30-degree angle. Or if the cosine came out to 1/2, that's a 60-degree angle. If it came out to something that we knew specifically, we could just say, oh, using that table, we know that those degrees. But since we don't, we have to use sine inverse or any of our inverse trig functions, whichever one is opposite, to get it all alone. So the measure of angle M equals sine inverse of 0.978, which in the end equals, going back to the calculator, sine inverse 0.97, oops, I don't know how 2 got in there, 978, yep, 978. So it would be 77.959, which we can round up to 78 degrees. So if we know the sine of a certain angle, we can find that angle just by using inverse sine. Same thing, if we know any of the trig ratios of an angle, you can use the inverse trig ratio to find that actual angle. Couple last examples here. A 5-meter long ladder leans up against the wall with the top of the ladder being 4 meters above the ground. So that's going to look something like this. Here's the wall, here's the ground, the ladder leans up against it like this. Ladder is 5 meters long, it is 4 meters high at the top. What is the approximate angle that the ladder makes with the ground? So that would be this angle right here that we're looking for. From this angle, we know the opposite side. Walls are always straight up and down, so this is a right angle, which means we know the hypotenuse as well. Now, whatever angle this is, we know that the opposite and hypotenuse tells us SOH. We know the sine. The sine of our angle, I'm going to call this angle theta. We'll see theta used a lot, this angle right here. Theta is used for angles a lot of times, so the sine of theta we know is 4/5, opposite over hypotenuse. So to get theta alone, angle theta equals sine inverse of 4/5, which means, going back to our calculator, sine inverse of 4/5, 53.1 degrees. So again, we didn't have to measure this one out. We didn't have to use a protractor or anything like that to measure this angle. We can just use these lengths to determine that that has to be for sure exactly 53.1 degrees. Okay, we have another situation. A ladder that's now 12 meters long leans up against a building. It rests on the wall at a point that is 10 meters above the ground. So here is the ground. Here is our wall. 10 meters up is where the ladder hits. This is 12 meters long. This is 10 meters high. This is, of course, our right angle. Find the angle the ladder makes with the ground. So our theta is going to be here now. It's going to be this angle. Again, from theta, we know the opposite and the hypotenuse. So we would say sine of theta equals, this time, opposite is 10 over hypotenuse, 12. So to get rid of that sine and to find just the measure of angle theta, you'd have to do the inverse sign on both sides of the equation. So it looks something like this, which means, going back to our calculator, inverse sine of 10 over 12. Oops, and I missed 0 here. Just plug it in. 10 over 12. Oh, run that. 56.4 degrees. So we write in, it's going to make 56.4 degrees. And that's how we would use our inverse trig ratios. That'll be it for 9.3.